Okay, last thing we did in section 4.8, and we'll go back and do one problem just to kind of remind you of some things. We were doing everything with the imaginary numbers and the complex numbers. The last thing we were doing, which is kind of where we'll set up here for this one, was we were multiplying numbers. We had something like this where you actually had to go back and do the full method on these. And the one big thing with multiplication was you would normally do it like any other full method. We would do 5 times 5, 5 times 7i. Then we would do negative 7i times 5, and then negative 7i times 7. So starting off with the top part, where we've got 5 times 5 for 25. 5 times 7i would be a 35i. Doing negative 7i times 5 would be a negative 35i. And then negative 7 times 7 was a negative 49. And when you do I times I, that was the one thing you have to be careful of. When you do I times I, that is I squared. Okay, when you're doing the full method, almost every single time there's always two things you're going to be able to do right off the bat. You should almost always be able to add or subtract these two middle numbers together. So we've got the 25 here. If you do 35 minus 35, we said that is 0i, and that's basically 0. So if you take 25 and add 0 to it, then that part's just gone. You don't have to worry about the 0i. With the negative 49i squared, that's where we're going to take the I squared out. That was the one time that you have to do something different. That you have to take out the I squared and replace it with negative 1. So that was 25. If you do negative 49 times negative 1, that was a positive 49. Then add those two things together, and that would have been 74. Okay, and what we talked about before was that when you're doing the full method with these different things, you can get all kinds of different answers. You can get an answer that's just a number. If these first and last two numbers wind up canceling each other out, you could have had an answer that had just been, like negative 16i. You could have had an answer that was like 25 minus 10i. So when you're doing the full method, there's all kinds of different answers you can get. One where you've got just a whole number, one where you've got just the imaginary number, and sometimes you'll have it where you've got both of them, that there's different parts there. But the main thing is that when you do these, you should have 4 terms, and the middle two terms should always be able to add or subtract together to get something where it's condensed down to one term. And the last term will always have the I squared in it, and that's where you've got to take the I squared out and replace it with negative 1. Alright, so that's the last thing we were leaving off with in section 8, was going back and doing the full method. And again, the adding and subtracting part, that part was the part we said should be the same, that you don't do anything different. There's nothing different that you do at all with addition and subtraction. You combine your like terms, and that's it. That's all you can do with addition and subtraction. When we do the multiplication, that's the one time we can do something different, where when we get I squared, you have to take the I squared and replace it with negative 1. Okay, and that's going to walk us up to the last thing as far as our operations go. The last thing is division. And division is not really, it's kind of like what we did before when we were doing simplifying parts. That division is not really division. It's really just a different kind of multiplication problem. So problem-wise, it'll look something like this. And it's, for this one, again, they all look a little bit different, but something similar to that. 3 plus 4i, and that's over 5 minus 2i. The biggest thing for this one is they do not like I in the variable, in the denominator. Again, that's an I, not a C, because they always, whenever they talk about the I term, it's always italicized. So for me, when I write it, it'll look like a C with a little bit of a gap in there, but that's an I. So when I talk about division, they say the one thing they don't want is the I in the denominator. So to fix that, so to eliminate the I from the denominator, we're going to do one thing. And this is where it's going to be more of a multiplication problem than it is really division. You're going to multiply the top and bottom of the fraction by the, I can't remember, I think we've talked about this before, by the conjugate of the denominator. Okay, did we talk about conjugate before? Or am I thinking about something else? Does that word ring a bell to anybody at all when we talk about conjugate? When the conjugate word, did we talk about that at all yet? Okay. Couldn't remember if we had. If not, here's where we're going to get it. Okay, here's what conjugate means. All you do for this thing. All you have to do to find the conjugate of something, it's like one of the easiest things in the world that you'll ever do. All you do is you just change the plus or minus sign in front of the I term. That's all you have to do. So if they ask you to find the conjugate, it's the easiest. All you do is just change one sign. That's all you have to do. Whatever the plus or minus sign is in front of the I term, change that one. So back up here when we've got 5 minus 2i, the conjugate is going to be 5 plus 2i. Okay, so all you have to do is just change that one sign. Some people are like, what if the first number is negative? It doesn't matter. The only sign you change is the sign that's in the middle, which basically is the sign that's in front of the I term. That's the only one that you change for this part. And here's what that's going to do. Okay, so we take that original problem, that 3 plus 4i over 5 minus 2i we had. If we multiply the top and the bottom by the conjugate, we're going to change that to 5 plus 2i. Now it's really a multiplication problem. And just to be on the safe side, we'll go back and put all these things in parentheses just to make sure we got it. Okay, on the top part, there's really no shortcut on this one that we're going to do. We're just going to go ahead and do the full method up here. So we're going to do 3 times 5 for 15. We're going to do 3 times 2 for 6i. Can't really go underneath it, so we'll just kind of go on the next part here. We're going to do 4 times 5 and then 4 times 2. So 4i times 5 would be 20i. And 4 times 2 would be 8i squared. Okay, and we'll come back and get the bottom part in a second, so let's finish out the top part. Okay, and when you do the full method, again, there's always two things you can do. The middle two terms, you can add or subtract those together. The good news is everything here is all positive, so it's just 20 plus 6 for 26i. And then the other thing that we're going to do is we're going to take out this I squared and replace it with negative 1. So 8 times negative 1 would make that a negative 8. Alright, so finishing out the top part. We've got 15 plus 26i, so the I stands by itself. You've got 15 minus 8, so that's 7, plus 26i. Okay, now here's why we do the conjugate on the bottom. Because if these two signs are different, if you notice, kind of back up here, let me scroll back up for just a second. Back up here, these two things, that problem we just did a minute ago, that was a conjugate because we got 5 minus 7i and we've got 5 plus 7i. And when you multiply by the conjugates, these two middle terms always knock each other out every single time. And that means that the I term just is going to go away. And at the end, we've got this I squared that's here. So we'll kind of walk through the setup on this one, but we'll show you the shortcut at the same time. Is that if we do 5 times 5, we've got 25. If you do 5 times 2, that's a 10i. If we do negative 2 times 5, that's negative 10i. And then we've got negative times positive, so that's going to be a negative 4i squared. Okay, and every single time you do the conjugate, these two things in the middle always knock each other out, so those parts are gone. And if you take the I squared out and replace it with negative 1, well, that's going to be 25. Negative 4 times negative 1 is going to be a plus 4. So that's going to make it just a 29 on the bottom. Okay. So when you're going through those, when they talk about division problem, it's really not a division problem. It's just really it's a multiplication problem that they've got written a different way. That when you go through those, you're going to multiply by the conjugate, and every time when you do that, those two middle two terms will always knock each other out, and then it's just going to be the first term plus the last term to get you one number on the bottom there. Okay, now the one other thing that they're going to do, kind of like we did earlier, they do want you to break this thing up as a separate fraction. So you've got 7 over 29 plus 26 over 29. And that way, if this fraction or that fraction will simplify, then you try to simplify it. But in that case, 7 over 29 doesn't really simplify. Neither does 26 over 29. So that'd be the final answer we're looking for there. So, and that's why I wanted to wait till today to talk about it, because even though it's division, it's really just a multiplication problem because we don't really do any dividing. The only dividing you do is at the very end when you break this part up into two separate fractions. Then you see if you can simplify it. But really, it's just a multiplication problem. Okay, and we can do 15 of those. They're all going to be the same thing. And basically, here's the shortcut for this one if you want to put it on the side. When you do the full method, it's really going to be the first term squared plus the last term squared. Because the O and the I will always knock each other out. So you could just do f squared plus L squared. Actually, let's do one more, and we'll make the top a little bit shorter. Let's just say the top number was 3. Let's say this was 7 minus 2i. Okay, so all we're going to do is we're going to multiply by and just change that sign that's minus, change it to a plus. Okay, and this one will go a whole lot faster than that last one did. Because on the top part, it's just distributed property. It's 3 times 7 for 21, and it's 3 times 2 for 6i. Okay, and if you got the conjugate like we've got here, it's always going to be the same thing. It's going to be the first term squared plus the last number squared. So when you do that, basically here's the shortcut you get to do. Actually, let's put it right here underneath it. The first term is 7, so that's 7 squared plus, and that's an L. The last number was, and you don't even need the I in this case, you just need the number. So that's 7 squared plus 2 squared. So this is when you actually kind of get to do the fluff method, because a lot of times people forget the O and the I when they're doing the full method. This one we call it the fluff method, because that's all you do. It's the first terms times the first term and the last term times the last term. So 7 squared would be 49. And 2 squared is 4. So that's going to make it 53. So final answer there would be 21 plus 6i, and both of those would be over 53. Okay, so that's just, and again, if you don't get the shortcut, if you just go back and do the full method, that's fine. It's not a huge time saver because the middle two terms will always knock each other out. So you'll get this number. It just takes 5 seconds longer to get there. So if you got the shortcut, that's great. If you don't have the shortcut, it's not that big a deal. But they just try to tell you, all right, if you do multiply the conjugates together, the middle two numbers always go away, and you're just left with the first number squared plus the second number, or the last number squared. And again, you look to see if you can simplify either one of those two. In this case, we couldn't, so that's as far as it'll go. Okay, and then the last thing we'll do, and this will be kind of a good review from what we did on Thursday. So it's section 8, but they're also going to go back to solving for this one little part at the end. This will be the last thing we'll do. But again, at the same time, this is also going to be a good review question. Okay, so test question-wise, you're going to have one in some parts of it. I'm going to say, all right, you can solve this thing ever how you want to do. You can solve it, you can square root it, you can complete the square, you can do the quadratic formula, ever how you want to do it. It doesn't matter. Go back and try it. So the first thing I would tell people is, all right, can you factor this one first? Well, let's see what we can do. The first number is not 1, so that means we've got to do the AC method. So if we do 3 times 2, be careful of your signs, that's a positive 6, right? So are there any factors of positive 6 where the sum would add up to be negative 1? Because that's basically a 1 that's in the middle there. Okay, now somebody's thinking, ooh, I can do 2 and 3, right? Now, be careful with your signs. Because if that's a negative 1, that means that's a negative. But what happens when you divide a positive and a negative? What do we get? If we divide a positive and a negative, we get a negative, right? So what happens? Can negative 2 and a negative 3, can those two things add up to get a negative 1? Negative 5, right? So the numbers are there, but the signs are a little bit off. So if we check it for this thing, there's nothing, this thing will not factor. So that factoring's out. Okay, now, if factoring is out, the only option you have then is quadratic formula. And somebody's saying, well, why are we doing quadratic formula? Well, because there's going to be one, we're still going to do it, we're still going to plug in the numbers. There's going to be one little thing different with this one when we plug it in. So we're up here, our A was 3, our B is negative 1, and our C is 2. So we're going to plug those 3 numbers in, and again, when we plug them in, let's put them in parentheses just to be on the safe side. That B is negative 1, so we've got minus negative 1, plus or minus. B is negative 1. We're we're going to square it. Minus 4 times A times C. That's over 2 times 3. Okay, so far it's just a practice of doing the quadratic formula. You've got a minus -1, so we're going to change that first sign to a positive one. We've got plus or minus. -1 squared. Now again, if you do b squared, that first number, doesn't matter what the sign is, it's always going to be just a positive number. So if we do 1 squared, that's 1. We've got -4 times 3 is a -12, times 2 is a -24. That's over 6. Okay, only one thing to do. 1 minus 24 is a -23. Okay, now everything up till now, we got a negative number on the inside. We said the answer was, anybody remember? If it's negative, that means it's no solution, right? So we said if you get a negative on the inside, it's no solution. For section 8, here's where they're going to go one more step. They're going to say, all right, well, because we've been taking out the negative, remember back in the very first part of section 8 on Friday? Oh, it's hard to remember back to Friday. But we said that if you take in a negative square root, you can take this negative out and replace it with I squared. So we're going to do the same thing here. We're going to take that negative out and replace it with I squared. Alright, now, if you check 23, though, that's a perfect square root number, because if you start dividing it by all the odd numbers, divide it by 3, it doesn't go, definitely doesn't go with 5. You check it with 7, doesn't go. So if you try to break 23 down, it won't break down. The only thing you can do is you can take the I squared out and put that I outside the square root there. Okay. Now, was anybody able to get? Did anybody in the homework did ever have the plus or minus button, or did they make you do 2 separate answers? It wasn't there. Okay. The ones you did had it. Okay. Because they in the past that's something I thought they knew that they'd added in. So for that part of it, that pretty much should be your answer. Because the 23 won't break down. You can't divide 6 on any part there. So the one thing they're going to do now is that if you get a negative answer in your square root, instead of saying no solution, which is what we've done up till now, just take out that negative and replace it with an I, and that I lets you know, okay, this is not a real number answer, it's an imaginary answer. So it's a pretend answer if you want to look at it that way. Okay, so that's the last thing we've got in section 8, where you have to do the quadratic formula, but the answer now is going to have the I term in it, so it's not going to be a whole number answer, it's just going to have an imaginary answer.